In this video, we will be tackling about alkenes and alkynes. Basically, alkenes and alkynes are chemical compounds containing carbon and hydrogen atoms.
Now let's focus on alkenes. Alkenes are unsaturated hydrocarbons that contain at least one carbon-carbon double bond or pi bond. They are from a homologous series with the general formula CnH2n. They are used as starting materials in the synthesis of alcohols, plastics, detergents, and fuels. First thing we need to know in naming alkenes are the common names of the alkenes from 1 to 10. 1 carbon alkene is known as methane, 2 ethane, 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, and 10 decane. We will still use the rules in naming alkenes, but instead of using the suffix "ane", we will use "ene" for alkenes. Let's start with a simple example. In this example, the entire molecule will be my parent chain. We can start from the left or the right side, but we must remember that we should pick the side where the double bond must receive the lower number. If we start from the right, the double bond will be at carbon 4. But if we start on the left side, the double bond will be on carbon 2. So, we must start counting from the left, going to the right, because our priority will be the double bond. Since there are 6 carbons on this molecule, this is a hexene, and we must specify where the pi bond is. The double bond is between carbons 2 and 3, but we will pick 2 because that is the first and the lower number between the two. The name of this molecule will be hex-2ene. Let's try this example. In this case, we should start counting on the left side because of the double bond in substituent. The double bond is at carbon 2, and a substituent, which is a methyl, because it is a 1 carbon atom, is also at carbon 2. This molecule is a hexene, so we name this molecule as 2-methylhex-2ene. In this example, there are 2 double bonds. Since this is a 7 carbon atom, this is a heptene. If we start counting on the right side, the first double bond will be at carbon 4. But if we start counting on the left side, it is on carbons 1 and 3. If there are more than 1 double bond, we will use the suffix di, tri, and so on. For this molecule, hept 1,3-diene. We use comma to separate numbers and hyphen to separate letters and numbers. In this example, it is a 5 carbon ring which is named as cyclopentene. It is not necessary to put 1 before the name because there is only 1 double bond in the molecule. And that is all for alkenes. Next up are alkynes. Alkynes basically are hydrocarbons that have triple bonds. Alkynes are unsaturated hydrocarbons because they have triple bonds in their chemical structure and consist of carbon and hydrogen atoms. The general structure of an alkyne is as you can see. The 2 carbons are bonded together by a triple bond, and one of the carbon atoms is connected to an R side group, and the other carbon to an R prime side group. The R and R prime can represent any group that consists of hydrogen and or carbon atoms. Now let's know more about alkynes. What do they look like? Alkynes are gaseous in form and they are soluble in organic solvents like benzene, and acetone, but they are insoluble to water. Alkynes also tend to be more acidic than alkenes and alkynes. Their boiling points are also higher than that of alkenes and alkynes. Now let's tackle some uses of alkynes. Acetylene, also referred to as ethine, is very useful because it can undergo several chemical reactions that are needed in manufacturing products in different industries. And another one is plastic, which is made using a compound called polyethylene, which is an alkyne. Now here are the common names of alkynes. 1. Methine. 2. Ethine. 3. Propyne. 4. Butane. 5. Pentine. 6. Hexyne. 7. Heptine. 8. Octine. 9. Nonine. And 10. Decyne. Basically, we still use the same rules in naming alkanes, but this time, we use the suffix "-ine" for alkynes.
Now let's tackle some examples. In this example, it is 6 carbon chain, and since there is a triple bond, this is a hexyne. If we name this by starting from the right, then the triple bond will be on carbon 3. And if we start counting from the left, it will be on carbon 3 also. So we can count in either direction. But in this example, we labeled the carbons from left to right, but it can also be done the other way. So the name of this compound is hex 3-ine. Now here we have a 7 carbon chain that has both a triple bond and a double bond. So this is a form of a heptine but with a double bond. Now it is important to remember that in priorities, the triple bonds and the double bonds are treated as equals. So in numbering, when both are present, we number from the end that is closest to a multiple bond. So the name of this compound is Het4N2-ine. Note that we insert the suffix en when naming an alkyne that has a double bond. In this example, we have a 7 carbon chain that has a triple bond, a double bond, and an ethyl substituent. Now in cases like this, our priority in counting will be the triple and/or double bond. So we number from the end that is closest to a multiple bond, and so in this case, we start from left to right. So the name of this compound is 4-ethylhep-2n3-ine.
Remember that substituents are second in priority when double or triple bonds are present.
Now we have a cyclohexyne that has a triple bond, a double bond, and a substituent. Now since we prioritize multiple bonds more than substituents in counting, we count in a counterclockwise motion. In this case, we start where the triple bond is because that way we achieve the lower carbon number compared to if we start counting by starting from the double bond. So the name of this compound is 5-propyl cyclohex 3N1-ine.
And that is all for alkynes.